I'm Anil Kumar. Welcome to my series on trigonometry. We'll discuss an application question and understand the concept of bearing angles. The question here is, Highway 400 runs north from Toronto, connecting many cities, including Barrie. Wasaga Beach is on a bearing of 210 degrees from Barrie and 290 degrees from Toronto. There are two parts to this question. Part A is find the shortest distance of Wasaga Beach to the Highway 400 if it is 120 kilometers from Barrie. And B is how far is Barrie from Toronto? So let's understand what bearing angles are and then we'll begin with its solution. So whenever we say bearing angle, so bearing angle is angle from north. And that to clockwise, right? So bearing angle means clockwise from north. Now based on this, let's make our sketch. So we are having the 400 highway which is going north. So on this highway we have 2 points. One we are saying Toronto, right? The other one we are saying Barrie. So that is Barrie for us and this is Toronto for us. Now it says that Wasaga Beach is on a bearing of 210 from Barrie. So 210 means 180 plus 30, right? So from here we go clockwise 210, kind of like this. Do you see that? So that becomes 210. So when I say 210, let me write down here, 210 degrees. That means 180 plus how much? 30 degrees. So this is 30 degrees for us. Okay. And the distance we are given as the Wasaga Beach to a highway 400 when it is 120 kilometers from Barrie. So this distance is given to us as 120. Well, this is a rather small diagram. And the shortest distance will be, of course, a perpendicular distance as I've shown here. Now we are saying that as far as Toronto is concerned, this bearing angle is 290, right? So let me connect this point first and then we'll talk about 290, right? 290 means what? 290 means, let's go with another color, more than 270, right? That much, correct? Something like this. So this angle here will be how much? This angle here will be 360 minus 290, which is 70 degrees. Correct. So that is how we can find that angle. So this diagram is really very small, but anyway, let's label this as Wasaga Beach W. And now we do have a diagram to work with. Let's figure out the solution. Let's say that the minimum point here is M. So WM is the shortest distance between Wasaga Beach and the highway 400, right? So this is let's say highway, okay, 400. Correct. Now find the shortest distance. So we do see that we have a triangle here where opposite side is given to us as WM, which we need to find. We know the hypotenuse, correct? So remember SOHCAHTOA? So we have sine, right? So we can use sine as opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Now in this particular case, we are interested in opposite side and we know the hypotenuse. So we'll use sine ratio, correct? So we can write down that sine of 30 degrees is equal to the shortest distance WM over the distance given to us 120, right? Let me write down, let's say WB for now. So WM is equal to 210 times sine of 30 degrees. Correct? Now sine of 30 degrees is half, right? So it is equals to 210, and sine of 30 degrees is half. We can do half of this. So let's 210 times sine of 30 degrees. If you use calculator, what you get is 105, which is expected. Let's write like this. So we get the shortest distance as 105. So that is one part of this. So we've done part A, which is 105 kilometers. Is that clear to you? Now let us see how to find how far is Barrie from Toronto. Now since we know the shortest distance, we can use the other triangle, correct? And find TM. We could do that. We can find BM. We could do that. So we can solve two triangles to find BM and TM. Or what we can do? We can use sine law, correct? We could do that also. So in this particular case, we'll actually use sine law to solve rest of the question. Now we know that the angle at W, which is BWT, is equal to how much? Now 70 plus 30 is 100, so it has to be 80 degrees. Correct? Now we can use sine law. We need to find the distance between Barrie and Toronto, so let's say BT, over sine of 80 degrees should be equal to, we can use 70 degrees and 120, right? So distance here, BW or WB over sine of 70, which is, so we know what BT is now, equals to 120 times sine 80 over sine of 70 degrees, correct? So let's find this out. So 120 times sine of 80 degrees, and we'll divide this by sine of 70 degrees. 125.76. Let's say 8 approximately to fund decimal place. So it becomes 125.8 kilometers. Is that clear? So that is how you could find distance from T to B, right? Now those of you who haven't done sine law yet can solve two triangles. So alternate. Solve two triangles. Perfect. But sine law is very convenient in this particular case. So I hope that helps you to understand this situation, and that is how we can actually solve such questions. I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.